In this tutorial, you're going to learn how to call external programs from your Python scripts. This is particularly useful as part of an automation script. For example, let's say you want your Python program to run the ls command and capture the output. On Mac and Linux, this command lists the files and directories in the current directory. This is equivalent to the dir or dir command on Windows. So in this lecture, you're going to learn how to run any of the operating system commands as well as external programs. For example, you can have your Python script execute another Python script. For that, we need to run Python 3, let's say other.py. So let me show you how to achieve this. On the top, we import the subprocess module. With this module, we can spawn a child process. A process is basically an instance of a running program. So with this module, we can run other programs. Now, in this module, we have a bunch of functions or methods like call, check output, and so on. All these methods are helper methods to create an instance of the popen class, process open. Now, these methods have been around for a long time, and they're kind of considered legacy. There is a newer method, and that is the preferred approach to create an instance of the popen class. That method is called run. So if you look at other tutorials or courses and they talk about these methods, remember there is a better approach, so don't waste your time on these methods. Now let's see how we can use the run method to run an external program. The first argument of this method is an array of strings. Here is an example. Let's say we want to run the ls command. So we add that here. Now, if you want to supply any arguments to this command, we add them as items in this array. So let's say ls-l, which gives us a detailed view of the files and directories in the current directory. Let me show you. So ls-l. Here's what we get. We get the name of the file, its creation date, size, the owner, and so on. So let's save the changes and run this program. As you can see, our program executed ls-l command, and this is the output printed on the terminal window. Now let's look at the return value of this method. So let's call that result and print its type. Run the program again. So what we get is an instance of this class, subprocess.completedProcess. So let's rename this variable to completed. Okay. Now look at the attributes of this object. We have args, return code, standard error, and standard output. Let's inspect each of these attributes. So I'm going to print this. Also, for clarity, I would like to add a label. After that, let's print return code and change the label accordingly. Next, let's print standard error, and finally standard output. So std out. Let's run the program and see what we get. So args is an array that includes the command that we executed. Return code is 0, which means success. Any non-zero values indicates an error. Now, in this case, because we don't have any errors, standard error is none. Otherwise, we would have an error message here. And standard output is also none because we are not capturing the output. The output is automatically printed on the terminal window. Sometimes we want to read the output of another program and do something with it. Perhaps we want to save it to a file. So let me show you how to do that. This run method takes quite a few keyword arguments, and all of these have default values. The one we're going to use now is capture output. If we set this to true, when we run this program, the output will not be printed on the terminal. It will be available in this attribute, standard output. Let's take a look. So save the changes. I'm going to comment out this line and run the program. So look, we don't see the list of files and directories here. The output is available in this attribute. So let's print that and see what we get. There you go. Now note that this string is prefixed with b, which represents a binary object. To convert this to a string, we need to pass another argument to the run method. So I'm going to break this down into multiple lines for clarity. Let's set text to true. Now when we run this program, we no longer see that B prefix, so here we have a regular string object. Now we can print this on the terminal window or save it to a file. As another example here, let's run another Python script. So I'm going to create a separate file here. Let's call that other.py. Let's say this is a complicated Python script that we want to call as part of running our main script. So for now, let's just print, here is a complicated script. Now back to app.py, we can simply run this script as a child process. So instead of ls, we want to execute Python or Python 3. And as the argument, we pass other.py. Save the changes, run the program. So as you see, the other script was executed, and here's the output that we captured. Now note that here I'm executing this other Python script as a child process. So it's going to be in a completely different memory space. This is different from importing that script and executing it here. So these two scripts will be in two different processes, and they will not share the same variables. So this is the basic of running child processes. And one last thing before we finish this lecture. Earlier I told you that any non-zero return code indicates an error. So let's take a look at a real example. We have this command called false. I'm not entirely sure if this is available on Windows or not, but if you're a Windows user and this doesn't work on your machine, please bear with me. So let's run this program and see what happens. As you see, our return code is 1. Because this false program always exits with 1 as the return code to indicate an error. Now, it's our job to check for this error. So one way is to check if completed.return code is not 0, then perhaps we want to print completed.standard error. The other approach is to pass another keyword argument here, check. We set this to true. When we do that, if there is an error, this method will automatically raise an exception. Let's take a look. So I'm going to run this program one more time. As you can see, we have an exception of type called process error. And this class is defined in this subprocess module. With this change, we don't have to check for errors like this. So we can wrap this code in a try block and then add the except clause. The exception we want to capture is subprocess.called process error. We can get the exception in this object and then simply print it on the terminal. So this is all about running external programs in your Python scripts.